is. And they don't want somebody watching the mail server in Maryland saying, hey, I know what their current location is. So that's a separate talk of what the sort of uses for Tor are and who cares about it. But the diversity of users contributes to its sustainability. It means that if somebody starts to pressure the Congress or whatever to make laws against security or anonymity or privacy or whichever way you're phrasing it, then we're going to have a lot of different people talking to them saying, hey, wait a minute, you can't take away my business security. I use that to look at my competition without them knowing what I'm doing. So that's one thing. That big pile of users also gives us a whole lot of IP addresses. And I'm going to make use of that in a few slides. Okay, and also anonymity is useful for censorship resistance. We talk to a lot of people who say, well, just ask your uncle to put up a relay. Maybe you're in China, you're at some factory, you want to tell about some problem at the factory. So maybe your uncle moved out of China and he lives in Ohio, and ask him to put up a computer, and then you can connect through that and you can post. That sounds great, except there are a couple of problems. One of them is, so I guess there are several issues. One of them is then somebody watching that relay can figure out, oh, hey, wait a minute, she communicated through that to the blog site. But maybe a worse one is if you look at the blog site and you say, hey, that thing that I wanted to censor, it came from this IP address. Hey, the guy who owns that IP address is the uncle of one of the factory workers. You can sort of trace back pretty straightforwardly and say, now I don't know for sure who posted this, but whoever did it knows this person, and now I'm going to start making some correlations pretty quickly. Or they can just spread suspicion that they're doing this sort of attack, and maybe people won't even do that in the first place. Okay, so that's a little bit. I'm halfway through. I've gone 30 minutes. Okay, great. Okay, so that's what Tor offers now, and I'm going to talk a little bit about the deployed solutions right now, and we'll sort of take what we like best out of them and go from there. So one of the important points here is there's sort of two components to these circumvention tools. One of them is called the relay component. One of them is called the discovery component. And we can break them down and look at them separately. So the relay component is, how do I actually build the paths through the servers? How do I actually do the crypto so I get it right? And then the discovery component is, how do I find that first thing that I want to connect to? How do I find some relay so I can get to the Tor network? Or whatever network we're talking about. In the case of Tor, this is pretty straightforward. We've mostly focused on the relay component. How do we actually build the paths right? And then we just tacked on a discovery component at the end. We said, okay, we need a way of finding the servers. Let's build directory servers, and we'll just use those two things. But the key point is that these are sort of separate ideas. How you do relaying once you know about servers, and how you learn about servers can be developed separately, and you can mix and match. Okay, so there are a couple of different schemes out there. On the one hand, we've got centrally controlled shared proxies. These are maybe big central commercial anonymizers. They've got a bunch of single hop proxies all around the world. They control and operate most of the proxies centrally from some big company, or maybe they hire a lot of people, and in their contract they write, please don't collude with anybody else who's in this contract. And the goal is a lot of different users get centralized in each one of these proxies. And they hope there's some anonymity there. That's sort of an open research question too, but it's not very promising. So these one-hop centralized proxies have weak security compared to a distributed trust design like Tor, because there's that one point of failure, you go to it, and now you win for all of the users using that. But they're really easy to deploy. You just put a proxy out there, and then you can even do it through the web, through a web browsing interface. You don't even have to install software on Alice's side. You just say, go visit that URL, and it'll take care of anonymizing you. So it's really easy to use, but we need to keep in mind that the reason why users don't need any new software is because they totally trust the proxy already, so what's the point? So that's something we can start with. On the other end of the spectrum, rather than something that aggregates a lot of users into a single place, imagine independent personal proxies, systems like Circumventor or CGI Proxy or Siphon. So they've got the same relay strategy. The relay strategy is easy. It's, I put a proxy out there and you proxy through it. There isn't much more to it than that. But the discovery component is different. In the first case, the discovery component was, hey, there's a URL and everybody uses it. That seems kind of easy to block. In this case, the new discovery strategy is find a friend to install it for you. I hope you have an uncle in Ohio or something like that. So this is great for blocking resistance. Nobody is ever going to notice that computer out there has one guy relaying through it every so often. If their goal is to find the top 10 IP addresses that dissidents use, that's never going to be on the list. On the other hand, there's a huge scalability question. How does the guy in China find the volunteer in Ohio if they don't happen to already have a relative there? And then the flip side of that is, let's imagine you're in Ohio and you really want to help out. How do you find a dissident who needs to proxy stuff through you? How do you actually get hooked up? So that's another building block we can use. Open proxies. Google for open proxy list. I don't need to tell the BlackHat audience about this. There are plenty of them out there. There are even companies in Russia that sell refined lists. They guarantee 30 kilobytes or better of bandwidth. They guarantee up. Who knows what else they guarantee in terms of operated by the Russian mafia. But these are out there, and there may be a tool that we can use also. Okay, so there's another system called the Java Anon proxy. It's built by the research group at Dresden. And it's a similar anonymity tool to Tor. There are a couple of differences in terms of what level of anonymity that they can provide and we can provide, but that's also a separate talk. So they have a similar idea to what I'm going to talk to you about in a bit. So their relay component, I'm going to skip over, but the discovery component they describe is a CAPTCHA. It's a little picture, it's got some letters in it, and they say, hey, tell me what's in the letters. And the idea is there's a rate limiting going on where they give you the little picture and you have to prove that you put a little bit of effort in, and then they give you an address. And as long as they've got enough addresses that the attacker isn't able to fill out CAPTCHAs quickly enough, then they're in business. Also not perfect, but it's something we can build off of. And then we've got Skype. It does port switching, it does encryption. It's a little bit hard to block. It still has a central login server, so it's not perfect. But they've got a lot of tools that we might be able to make use of. They look like SSL. They try to move around and find which ports aren't firewalled. And then there's Tor itself. Tor's website is blocked in a lot of places. It's blocked in Iran. It's blocked by the LA Times. I was talking to a reporter earlier, and they really wanted to do a story about Tor, except they couldn't read the Tor website because whatever proxy program they used to filter their corporate internet wouldn't let them read about Tor because it was scary. So the Tor website is blocked in a lot of places, but the Tor network is blocked in almost no places. So why is that? I mean, aren't we a circumvention tool already? Aren't there tens of thousands of people who are using it right now to get around their government firewalls? So there are a couple of speculations. I mean, the easy answer is, gosh, I don't know. Why don't we ask them? But they haven't told me. So one speculation is, sure, there are 30,000 people in China using Tor. So what? 30,000 is zero. They've got a lot of people there. Nobody cares. That could be. Another answer is that the perception that we've been giving out so far is Tor is for experts. If you want to set up your Tor right, you need to be able to edit a file. And right there, I just shed 99% of the users that we might have. And as long as we continue to sort of work in that paradigm, again, nobody's going to care. And then another perception, another possibility, nobody has publicly threatened their control. As long as we keep talking about how useful Tor is for civil liberties and for the law enforcement and military and companies and so on, then we're not going up there and saying, hey, this is a big deal about human rights. And as long as we're considered to be a free speech tool, then we're not a human rights tool and they don't care. More importantly, the folks who are building the block lists and the folks who are wondering what they should block don't consider this a threat. But I guess the key point is we're already in the arms race. For all those people who say these attackers are super powerful and super dedicated and they'll block everything and they'll make sure to look inside all the steganography, they don't. It's working. So, I mean, it's not going to keep working forever, but we're already in the arms race and we've taken several steps, so we should learn a little bit more about that and maybe we can make use of that also. And we can learn a little bit about the priorities and the constraints of the various attackers that we've got right now. Okay, so that's a little bit more about that. So what do we need to add to Tor? What are we going to what components are we going to try to build in order to build a system like this? So the first point is we've got a lot of users. What would happen out of these hundreds of thousands of users, and they're already self-selected for caring about privacy, what would happen if we took the Tor GUI called Vidalia and we put a little button in it that says Tor for Freedom? And when you click the button, then you turn into a relay. You don't volunteer to be a server in the main network. You don't publish to the main directory authorities, but you publish somewhere else. And you rate limit to 20 kilobytes a second, which is nothing for somebody on cable modem, but it's a whole lot for somebody on a modem in a RAN. And these can be internal relays. They don't have to be exit nodes. They're just bridging from the blocked area to Alice to the Tor network. So Alice, in this case, is the bridge. She's going to be an ordinary Tor user. She does her own Tor stuff, but she clicks the button, and now maybe some blocked user can relay through her into the Tor network. So the idea is maybe if we've got a few 100,000 of these Alices and maybe 10% or 20% of them end up clicking the button, now we've got a lot of IP addresses to work with. And maybe we can do something smart with those in terms of the discovery strategy. Okay, so once we've got these bridge relays, we also want to add a new concept called bridge directory authorities. You run a bridge relay and you publish yourself to the bridge directory authority or the bridge authority. And that way it can aggregate a bunch of different volunteers who said, yeah, I'm okay with people relaying through me. I'd like to, Tor for freedom. Yes, good. And at that point, the key difference between these directory authorities and the main ones is we don't give out a big list. The main directory authorities say there are 1,000 servers and here they are. And you can also do individual updates. You can say, I know about a server with this identity key. Can you please tell me his newest descriptor? And the descriptor includes current IP address, keys, exit policies, stuff like that. So the idea is for these bridge authorities, you can, if you already know the identity key of your bridge, you can query the bridge authority and say, hey, where did you move now? But if you don't know the identity key already, then there's no way for you to learn the whole list. And I'll talk a little bit more about how all of that works in a bit. But then I guess the other point is the identity key and the address for the bridge authorities should ship with Tor along with the main bridge authorities. And also bridges should publish to the authority using Tor. Otherwise somebody should just watch the bridge authority's network and they'll learn about all the bridges as they show up and sign up. But if you use Tor, then there's no central place to watch to see who has volunteered. Once we have an anonymity system, we can use it for all sorts of things inside the anonymity system. Okay, so another key point here. Once you've got one bridge, we're good enough. Once you've bootstrapped to the point that there is some bridge out there that you can use to get to the rest of the network, then we've gotten past the hard part. And at that point, you can use that bridge to connect to the Tor network, to connect to the directory authorities, to connect to Voice of America or Indie Media or whatever pages you want to do. Once you've got one bridge working, then we're done. Then we've solved the discovery problem, and you can continue to bootstrap from there. And all of this happens in the background. So once you've got one, then Tor will just automatically take care of building the circuits for you and take it from there. So we've changed the problem from the situation they're in now, which is how do I circumvent my firewall for every single transaction and trust that I'm actually getting the right pages back rather than a page that says, it seems that you're looking at a page you shouldn't look at. Have you considered